Hey guys, in this video I'm gonna be quickly speed running a level 2 calculus paper from 2012. So let's go. Question 1, function f is given by, alright, so basically this one we need to differentiate, so f dash of x will be equal to 6x squared minus 10, then at x equals 2, so f dash of 2 will be equal to 6 times 2 squared minus 10, which is equal to 24 minus 10, which is equal to 14. And the next part for function p, p dash of x. So find the function. Okay, so we're given a differentiated function, so we need to integrate it to get p of x. So the integral of p dash of x will be p of x. So the integral of p dash of x is equal to the integral of 4 minus 6 times the integral of x squared, which is equal to 4x minus 6 times x cubed over 3 plus c, which is equal to 4x minus 2x cubed plus c. And when x equals 2, y equals 5, so p of 5 is equal to 4 bracket 2 minus 2 bracket 3, 2 cubed plus c, and therefore, I can just write 5 is equal to that, and then 5 is equal to 8 minus 16 plus c, 5, which is 5, which means that c is equal to 13, and so p of x is equal to negative 2x cubed plus 4x plus 13. Alright, moving on. The distance s of a tractor from a gate post in meters is modeled by what is the time on this interval. So the velocity is equal to ds over dt. So and ds over dt is equal to 0.2 t plus 5, and which is equal to 8, and 0.2 t plus 5 is equal to 8, and then 0.2 t is equal to 3, and therefore t is equal to 3 over 0.2, which is 15. T is equal to 15 seconds, and the time in seconds, yeah. Right, cool. And the fuel consumption F of a car in liters per 100 kilometers is related to the velocity by the formula. Show that the fuel consumption is a minimum when v equals 25. So since we're finding minimums, we're going to first differentiate and then let equal to 0. So we're going to start by saying df over dv is equal to negative 0.2 plus 1 over 250 times the derivative of v squared, which is equal to negative 0.2 plus 1 times 2v, which is 2v over 250, and then we're going to let it equal to 0, so negative 0.2 plus 2v over 250 is equal to 0, 2v over 250 is equal to 0.2, and so 2v is equal to 250 times 0.2, which is equal to 50, and so v is equal to 25. And yep, moving on. A train starts from rest and its acceleration is given by 4. So first I'm just going to expand that. So a is equal to 5 minus 1 over 4t. And so the first integral of a will give me the velocity. So the second integral, if I integrate it twice, then I'll get the distance. So I'm just going to do it. So the first time we do it, we'll get that v is equal to the integral of 5 minus 1 over 4 times the integral of t, which is equal to 5t minus 1 over 4 times 1 over 2t squared, which is equal to 5t minus t squared over 8. And then if we find the integral of the v, then we'll get 5 times the integral of t minus 1 over 8 times the integral of t squared. And speaking of the integration constant, when t is equal to 0, and then the so no, and then so this is going to give us that, and I should just write note that the integral of the velocity is equal to distance, which is 5 over 2t squared minus 1 over 8 times 1 over 3t cubed, which is equal to 2.5t squared minus t cubed over 24, and I believe it's t equals 30, so I'm just going to t equals 2.5t squared minus t 24, and then so d, which is equal to 2.5, get 30 squared minus 30 cubed over 24, which is equal to oops. Which is equal to 2250 minus 125, which is equal to 112, 1125 meters. Yeah. And then the next one, okay, let's drop those. When I find the x coordinate of the point on the graph h of x equals x squared when the gradient is equal to 4, so h dash of x would be equal to 4, therefore 2x minus 12 is equal to 4, 2x is equal to 16, x is equal to 8. Find the equation of the tangent to the curve at the point 1 comma negative 11. So what's the first? I think I need to find the gradient because y minus y1 equals m bracket x minus x1. So I need to find the gradient. So h dash of x was basically 2x minus 12. H dash of 1 is equal to negative 10. And then I can use these points. So y plus 11 is equal to negative 10 bracket x minus 1, which is y plus 11 is equal to negative 10x plus 10. Therefore, y is equal to negative 10x minus 1. And g of x is equal to x cubed minus, for what is it, a decreasing function? So this means that for what values is its derivative less than 0? So for what values is g to x less than 0? So differentiating g of x, we got 3x squared minus 18x plus 24. And then since it's a quadratic using GC, 2x intercepts is 30, negative 18, 24. So x equals 4 and x equals 2. x1 equals 4, x2 equals 2. And then our interval is going to be when so if I were to graph it, that's terrible. If I were to graph this function, and say that's 4, that's 2, then this area here is when x-axis is negative or less than 0. So my domain is x less than 4 greater than 2. And I must justify my answer using calculus. So a value between, let's say x equals 3, right? So then g dash of 3 will be equal to be equal to 3 bracket 3 squared minus 18 bracket 3 plus 24, which is equal to 3 times bracket 3 squared minus bracket 18 times 3 plus 24, which is negative 3. So negative 3. Hence the is which is negative 3 is less than 0, so therefore it is a decreasing function. Area for the triangle Okay, I'll have to come back to that one. Curve y, because so if we find let's do the origin 0, 0, which means no y, and okay, so find y is equal to x cubed over 3 minus x squared, and then since it passes through the origin, means no plus or minus c as an integration of constant, and y equals f of x, so f of x is, so there's no plus c. Find the coordinates. So y is equal to 6 cubed over 3 minus 36, which is equal to 6 cubed over 3 minus 36 is 36 is equal to 36. So when x is equal to 6, y is equal to 36, hence the point 6, 36. And then so v, so the rate of change of volume, so dv over dx equal to 3x squared when the side is 5 centimeters. So when x equals 5, they're finding the rate of change, so 3 bracket 5 squared, so equals 75. So dv over dx equals 75. They've just given centimeters, they haven't given any unit of time, so I'll just ignore that. Okay, curve f of x equals 2x cubed plus ax plus b. Okay. Right. So f dash of x will be equal to 6x squared plus a, and then it has a gradient of 10. So 10 is equal to, at x equals -2, 6 bracket -2 squared plus a. So 10 is equal to 24 plus a. So a should be equal to minus 14. So I can rewrite this as f of x is equal to 2x cubed minus 14x plus b. So I know that f of x passes through this point here. So 33 is equal to bracket. Oh, no, that bracket should be there. Is equal to 2 times bracket -2 cubed minus 14 times -2 plus b. 33 is equal to 2 times -2 times -2, 4 times -2, -2, -8 plus 28 plus b. So 33 is equal to -16. 28 is 12, so 33 minus 12 is 21. So equals 12 plus b, so b equals 21. Hence, finally I can write that f of x was equal to 2x cubed minus 14x plus 21. But find the coordinates when x equals 4. So I'm just gonna make a statement. F of x equal y, so y is equal to was that 4? Yeah, 2 bracket 4 cubed minus 14 bracket 4 plus 21. So I'm just going to get the coordinate ready. 4 comma 2 times bracket 4 to the power of 3 minus bracket 14 times 4 plus 21, 93. That's 4 comma 93. That's the point. Chemical is dropped into the water. After 0.1 minutes, the chemical spreads in a semicircular shape with radius r meters, where r is equal to 1 minute. When the chemical first reaches the far side of the pool, the area, so the far side, the area of the semicircle is increasing. So area, find the width of the pool. Right, so the area is increasing at this rate of 60. So if area is equal to pi r squared, then the rate of change of the area, which is dA over dr, will be equal to 2 pi r, which is circumference, or basically pi times diameter. And the area is increasing, so I know that dA over dr is equal to 60 meters squared a minute. So 2 pi r is equal to 60. Therefore, r is equal to 60 over 2 pi, which is equal to, or 2 pi r is the same as pi times diameter, so that would be the whole width of the pool. 60 divided by 2 by 9.549, 9.55 to 9.55 centimeters? No, meters squared, yeah. 9.55 meters. Alright. And this is just spare graphing paper. So, yeah, that's this calculus paper speedrun by me.